And we'll share the screen. And I have pulled up here our topic 6 folder on the class repository. And there's a set of handouts for the next quiz, not this Wednesday, again, this Wednesday. So next class period, we'll be having a second quiz on recursion, doing a little bit more harder problems. And I tried to highlight as we were going over the last quiz some of the things that you should expect. And again, the going over the last quiz is all recorded, so you could use that as a review if you would like for the coming quiz. And another thing about the coming quiz is that all the points will be worth double. So the quiz on recursion on Wednesday will be worth 8 points instead of 4 points. The notes that I passed out today, this quiz practice.pdf, if you're looking for an electronic version, is not for this Wednesday, but for next week's quiz. Good thing about this handout, I think, is that we'll be going over it today, and I think what you'll all see, what most students find, is that the topic here is going to be a lot easier than recursion and a lot easier than most of the quizzes that you've had. So that's nice, I guess. We're gonna start class today going over this quiz practice.pdf file, and then there's this Python file down here, yieldexamples.py. We'll get to that probably by the end of class and probably finish up this file here on Wednesday, next class period. But if you're planning on following along when we get to that, getting that pulled, doing the git pull upstream master sort of command to get that onto your Lambda server account would be a good thing to do. A couple more quick announcements before getting into the technical stuff, again, starting with the quiz practice today. We got a lot of topics listed up here from in this little title thing. Most students, again, find the object-oriented part and this class keyword that we're going to talk about as part of the quiz. Most students find that to be relatively intuitive, but this other stuff out here, which is not going to be on the quiz, but will be on the homework, this is where things will get tricky and weird and confusing this week. So announcements again, grades. I really am very sorry about this, but I'm pretty behind on grading everybody's stuff, just getting it transferred over from GitHub into Sakai. I apologize for that. I always hated as a student not having up-to-date grades and knowing exactly how you're doing in the class. My hope is that you should all have a good sense of how you're doing in the class, because all the things are graded. They're just not entered into Sakai. That GitHub has been grading them for you. So you should know roughly if you're how you're doing. We've now officially have a grader in this class who can do all that work of transferring over things from GitHub into Sakai. It just took a long time for the administrative paperwork and stuff to get through for that. But hopefully by the end of this week, all the stuff will actually be in Sakai and you'll be able to take a look at it and know exactly what your percentage grade is. But again, I'm sorry it's taken this long. Another last announcement. So the next 4 homeworks that you'll have in this class, so this week and the next 3 weeks, they're all going to be building on each other. And so it's very important that you do well on these earlier homeworks, because you can't do the later homeworks unless the earlier homework is completed correctly. So the main idea of these homeworks is sort of up until this point, we've been using other people's data structures, especially the ones built into Python, like the list, tuple, but we've also been using this array and talking about their performance, runtime characteristics, why you might want to use one versus another in a different situation. But now we're going to be creating your own data structures, and we'll see about how to do that starting today. At the end of this, at the end of these 4 homework assignments, you'll be actually publishing all of your containers, data structures that you're writing as a library on what's called PyPy. And anybody in the world will be able to download and use your code. So this is a cool thing that you can talk about to maybe future interview situations, talking with employers, telling them about how you have this library out there and you at least know how to go through all these steps of getting code published so that other people can use it. In terms of like these 4 homework assignments, difficulty levels to expect. This first assignment, I'm calling it easy in like scare quotes. That the assignment is like getting the actual concept behind the assignment is a little bit hard, but once you have this concept, there's no like tricky edge cases and things to debug. Like once you feel like you understand things, it'll be really easy to do. That'll be in contrast, though, to the next 3 assignments, where not only is there like a hard underlying concept to understand, but there will also be lots of really weird, tricky edge cases that you'll have to fight Python with. And so the next 3, expect them to be particularly hard. Yeah, so in general, when coding, working on projects, they always take longer than you think they're going to. And so a common rule of thumb used by software engineers is whatever you think your project is going to take, whatever you estimate is, like I think it's going to take me 10 hours to do this week. Just always multiply your estimate by pi. And by pi makes the estimate a lot bigger, but it's also just like a totally arbitrary thing that we don't, instead of just saying 3, we say pi just to emphasize how arbitrary this estimate is. And even though when you do this next little comic I have right here is talking about how estimates are always way off, that these guys are looking at their book here of pictures from 3 years ago. And 3 years ago, they were estimating that their business would be live in 2 months. And it's taken them 3 years to get there. Okay, so next we're going to be going over that quiz practice problems file. Before we get there, though, any questions on anything administrative in the class? Yes, Abizar. Question is, will you get more time than 8 minutes on the next quiz? And the answer is no. It's still 4 problems. It's just each problem will be worth 2 points instead of 1. And again, if you want extra time on the next quiz, especially since the problems are going to be harder, you might want the extra time. I will be here. I'm usually here like at least 20 minutes earlier. There's always only like 2 or 3 students when I first get here. So you're welcome to come very, very early if you would like to get more time on the quiz. But my intention is that everybody should be able to do the quiz in just those 8 minutes. But if you want more time, you're welcome to it. Any other questions? Okay. For this quiz practice.pdf file, I'm going to go through the problems here in Python Tutor so we can visualize exactly what's going on here. And what I have up here is the first problem on those practice problems. We'll walk through what's going on in this first problem, and then I'm just going to start making changes to this Python tutor to illustrate all the key ideas, but I'm not going to follow the practice problems exactly after this point. Here, so the new first key idea here is this class keyword. And when I press next right here, you'll see that this foo right here is now a variable that we can reference. Anything that is inside one of these frame objects is a variable that we can reference. And the things that are inside of the class, they will end up being well, we'll see what's going to happen here when we start adding things inside the class. At this point, all we have is this pass keyword. This is another one of these reserved words in Python. You may or may not have seen it before, but pass just means that anytime you're after a colon, and if you're after a colon, you have to have something that's indented, and pass means that we just don't want to have anything. So this is a common, what we call an idiom in Python, meaning that we're creating a class, and this is like the simplest possible class. It has nothing inside of it. On line 3 right here, you can see that we're we have this foo keyword again, and we're using it like a function. It has these parentheses right here. This is what we call constructing an instance of this class right here. I'm going to press next down here, and we'll see what happens over here. You can see it says foo instance over here. And an instance of a class is something that we can attach what we call attributes to. Anytime you have a period in Python, so you've interacted with this dot operator many times, anytime you have this dot operator, the thing to the right of it is what we call an attribute, and the thing to the left is what we call an object. So an object in Python is just something to the left of a dot, and an attribute is something to the right of a dot. And so here, over here on the right-hand side in our output over here, you can see there's this list of objects. All of these things over here are things that can be put to the left of a dot, and so that's why they're listed in this objects area over here. When I press next on line 4 right here, a.message equals hello world, you can see that it adds this little sort of box over here under the instance for foo right here. This foo instance right here, again, is created with this foo function right here, and we assigned it the variable name a right here just with line 3. The way to read this box over here is the thing in the orange. The darker color is the name of the attribute. So message right here to the right of the dot. This is the name of the attribute. This is the thing in orange over here in Python Tutor. The thing in yellow over here is the value of this particular attribute. So it says hello world over here because it said hello world right here. That's what we assigned to this attribute. On line 5 right here, we're going to create another instance of this foo class. I'll press next, and you can see that it's a totally separate instance down here that's been created 100% independent of this instance right here. They don't interact with each other in any way at all. And so here on line 6, when I do b.message right here and say hola mundo, this is going to create under this foo instance down here, this message right here that corresponds with hola mundo right here. These try and accept blocks, all of your quiz problems, the final print statement is inside one of these try and accept blocks. We'll see what exactly causes this attribute error here in a little bit. But when we run on line 9 right here, when we do a.message right here, try to print it out. Because we have an a to the left of the dot, the object that we're looking at is the object referenced by a. So take the a arrow right here, follow this arrow over to this, and then we get the message over here, the message over there, right here, and it says hello world. So when this will print out a.message, a right here, message right here, getting us hello world right there. Press next, and we get hello world. I'm going to do some variations on this so that we can see where the weird cases are, and then I'll stop for questions after we do the variations. So the first variation is just changing this a.message. Let's print out b.message down here like this. And you'll see that now when we get down to the end, it's going to come down here to this instance instead of this instance up here and print out hola mundo instead of hello world. So this, we have sort of two different variables. This message variable, they have the same names, but they're inside two different objects, one referenced by the a variable and one referenced by the b variable. And so even though we have this same variable name, because it's in two different objects, it can have two different values. And really, when we're using classes, the most common use case for this class keyword is because somehow we have this common variable that we want to have like multiple messages, but we want multiple messages with different values, and this class keyword allows us to do that. Let's edit this code again. And I'm going to see what happens if we take away this b.message right here, delete that line. So we're creating the b instance, but never adding a message attribute to it. We'll press next, next, next. Line 5 right here, We run that, and you can see we create that B instance right here, but it has no message inside of it. And so down here on line 7, when we do b.message right here, this message does not exist, and so this is going to throw the attribute error or raise the attribute error. Because this message right here does not exist, it's going to raise the attribute error, and we get this error message right here. Going next, the except clause right here catches that attribute error, and then we print out attribute error up here. At this point, it'll be relatively obvious when we're getting this attribute error. It's just whenever you have something to the right of the dot that does not exist inside of the instance over here. We'll see some weirder edge cases here in a little bit, but it's just if there's something to the right of the dot that doesn't exist, then you get the attribute error. Let's do a couple more variations here. I want to have multiple attributes inside a single object. So a.message, and we'll do I'm going to use a.foo right here, this capital foo right here. This matches, you can see this matches this up here, but that's okay. This will be referring to something different than this up here because this is to the right of a dot. This right here to the right of a dot, this up here not to the right of a dot. So we'll do hola mundo like this and visualize that execution. And that's totally okay. You can see that it just creates two different things down here, two different of these attributes inside of this instance, and we can access either of these attributes if we want to. So over here we can do a.message, and we'll also print a.foo like that, print that out. And we can access any attribute that we want in any order that we want, and that's 100% okay. What we're going to talk about next is up here in this class, what we have as alternatives to this pass right here. So we'll edit this code, and I'm going to, we'll leave that in for now. And then up here, let's add a message right here. And this message will be Salve Mundi like this. So get our Latin hello world going. Visualize that. And when I press next right here, you can see that there's a difference now between this foo class object right here and what we had before. Before, there was nothing, there was no like yellow box inside of the foo class over here, but now there is a yellow box, and each one of these attributes matches what is to the left of an equal sign in the class, and the value matches whatever we put to the right of the equal sign over here. Now when I do line 3 right here, I say a equals foo. We have a down here and this foo instance, and I do a.message. And because this message right here is to the right of the a, we have a.message right here. This is not going to affect this up here. It's not going to affect this up here. It's going to affect the instance down here for the a variable. The instance that the a variable references is what this message will refer to. So I'll press next right here. That's still going to be hello world. And we'll go ahead and do that rest of the lines. And when I do print a.message down here, print a.message, it's still going to the a class right here, or the a variable, follow the arrow, get the message, and print hello world. So at this point, this line 2, this change we made up here, the only thing that's happened that affects what Python Tutor is doing is this yellow box right here under the foo class. It now has this available to us. We can access that by down here. I'm going to just keep adding more print statements down here so we can compare all the different ways of accessing these variables. I can add this foo.message like this equals, comma, foo.message. And the key difference about what I'm doing down here is that this is the capital foo right here. This is the class up here. This is the class name right here. And so when I do foo.message, it's going to access the message inside of the foo class like that. visualize execution. Again, anytime we have I'm going to review the vocabulary right now, that this is an object over here. Anything that's listed to the right over here is an object. And an object can appear to the left of a dot. Anything that appears to the left of the dot in Python terminology is an object. And the thing that appears to the right of the dot is an attribute of that particular object. So this message right here is an attribute of the foo object. So this object right here, this attribute right here. And so the only change was I added line 10 here at the bottom. We'll just jump ahead to line 10, and we'll see that this foo.message is how we're allowed to access a variable that was created up here inside of the class itself. Let's do one more example now about why we might want to have, what did I do? Why might we want to have a variable up here, a variable inside of the class, instead of a variable that is part of the instance. And we'll do that by down here saying print b.message equals comma b.message. So we had this line earlier. We saw this line earlier, but we took it out to rerun some of these other tests. In this case, previously what happened with this line was we got the attribute error down here and we printed attribute error as a result. Now what's going to happen though is something different. Let's walk through it. Again, everything up to line 11 here is the same as before, so I'm just stepping through until I get to line 11. And I know I'm on line 11 next because the red arrow here is pointing at line 11, still printing out the same results over here. And now on line 11, when I do b.message, trying to access the b, and so again here, b is the object that I'm accessing. B is the object that I'm accessing because it's to the left of a dot. The attribute that I'm looking for is message, and I know it's to the right of a dot, so that's why it's an attribute. I take the b variable over here, and I follow this arrow over here to this foo instance, and I can see that there is no message inside of this foo instance. And previously, we were getting an attribute error when that happened. Now we're not going to get an attribute error though, because the foo instance, if you don't have an attribute inside of your instance, it will look for that attribute inside of the class. We know this is a part of the foo class because right here it says foo. And so it's going to look inside of the foo class right here for the attribute message. It's looking for the attribute message because message is to the right of the dot. And when I press next right here, you can see it gives me my Salve Mundi right here because it did not find anything right here, but it did find it up here, and so it prints Salve Mundi. Here, the important thing about this is that you'll notice that when we do a.message right here, message is an attribute of the a object. Take the a variable, follow the reference to the object over here. Message does exist inside this object, so it prints out hello world, right here. But and it does not follow backwards up to the class to get this message right here. The b variable references this instance, this object down here. This object does not have a message attribute. And so instead of immediately throwing an attribute error, it goes back up to the foo class and looks inside the foo class for the particular attribute. And it finds it in this case and does not throw the error. Pause now for questions before we go on. Yes. So the question is right here on line 4, if we took away line 4 like this, so there is no more a.message being assigned, and step through this, then what's going to happen on line 8? And this will behave the same way that our line 11 was previously behaving, that we do have some attributes inside of this foo instance right here. We have this foo attribute inside of the foo instance, but we do not have the message attribute. The message attribute is the one that we're looking for in this line right here. And so it's going to go back up to the foo class and get the Salve Mundi. Did that answer your question? Your question? Yes. Yeah, the question is, how important is this line 3 right here? What's going to happen if we don't have line 3? And line 3 is critically important. Line 3 is what actually creates the object over here on the right-hand side. And so if we don't have line 3, then it's not going to work. Line 4 right here, so we notice that we skipped over line 3. We're not executing that. So there is no A variable inside of this global frame over here. There is no object created over here. And so when I press next right here, we get this name error saying name A is not defined. Name error right here saying name A is not defined because we have something to the left of a dot, and that thing to the left of the dot, the name of that variable does not exist inside of this frame, this blue box right here. For those of you who took CS40 with me, roughly at the end of the semester, we had a quiz on the different types of error messages, the different types of exceptions that Python can throw. And we talked about how name error and attribute error were basically the same thing, but a little bit different. And the only difference between a name error and an attribute error is a name error is when the variable to the left of a dot does not exist, or if there's no dot at all, then you'll get a name error if that variable does not exist. An attribute error is when the thing to the right of the dot does not exist. And but a name error and an attribute error, basically the same thing. You should think of them as the same thing. It just means that whatever the variable is that you're trying to access has not been defined anywhere. And in this case, it's the A that has not been defined. And so you're getting the name error. For the purposes of the quiz, the only errors that will happen will be the attribute error. I will always define the variables here, actually define the object for you, define all of the names to the left of the dot. It's just the attributes to the right of the dot, which may not be defined. Did that answer your question? Yes. So the question is, do A.message and B.message refer to the same variable, the same thing in memory? And the answer is no. And this is a key thing that you need to be aware of. So just put a test right here for B.message. And let's walk through this and see what's going to happen. So we've just executed line 7 right here. The only difference between this code and the previous code that we were talking about is that I added this line 7, which has a B.message. And so now you can see there is an A.message and a B.message inside of here. And looking over here on the right-hand side under the objects, you'll see there are these two instances right here, one referenced by A, one referenced by B. And they both have the same attribute name. They both have the same attribute message right here, but the values of those attributes are different. And so whenever you're referencing an instance of a class, whenever you're referencing an instance of a class down here on, say, like line 9, trying to get the message of A, right here, even though up here we set the message of some sort of foo class to be equal to test, that is a different instance, it is B that we set to be equal to test. And so on line 9, we will print that out and get hello world right here. So there's a handful of these sort of rules that you'll have to just become comfortable with working through these quiz problems and eventually the homework. Once you get these rules down, though, they will become very intuitive if they're not intuitive at this point. And there's not too many weird edge cases that are going along with this. This syntax right here, we call this the syntax for creating the attribute or setting the value of the attribute. This syntax is not normally used in practice. And in practice, we do something different using something called a constructor or an initializer. So I'm going to demonstrate what that looks like next. Deleting a bunch of lines here. We're sort of totally resetting what we're thinking about. And in terms of the notes, I think this is a whole nother section in the notes that we're moving on to. This is essentially the first problem in the constructor section of the notes right here. What we've changed about this foo class is now there is a function being defined inside of the foo class right here. This function has a number of special things about it. The first thing that's special about it is that it's inside of a foo class. Anytime you have a function that is inside of a class, it is traditional for it to have the first name of its parameter to be self. So this, anytime you have a function inside of a class, the very first parameter to that function will be called self. And self will always refer to a object. We'll see that in a second when we actually run this code. Here, we have a second parameter to this function right here, message, and this is going to be something that we'll actually have to provide whenever we call this function. This value right here is not something that we're going to have to provide. It's going to be provided for us automatically. This function right here is special in that it is the function that gets called whenever you create the object or create the instance of this class. This class is called, or this special function is often called a constructor because this is the function that constructs the instance of this class. Here, this constructor takes one argument right here. When we're counting arguments of these functions inside of classes, we only count the number of arguments after this self. So this takes one argument right here. And so I have to provide an argument to this function now. Here, I'll do hello world like that. And on line 6, I will do hola mundo. And this is going to give us an alternative syntax, an alternative way of basically doing the exact same thing that we did on the very first problem that we were looking at here. I'm going to walk through this. We'll visualize this execution, and then I'll basically repeat everything that I just said. So if you didn't catch everything, then you'll have a chance to hear it all again with the visualization going on the right-hand side. Again, when we're creating the class object right here, we never go like inside of it and step through it line by line, just like when we're defining a function. We never step through it line by line. We just jump over that and come down to the next line down here, line 5. Over here on the right-hand side, though, you can see that we have this foo object, and this foo object now has this function inside of it. The attribute of this function, the name of this function is the attribute. So underscore underscore init underscore underscore like this is the name of our attribute, and the value of that attribute is that it is a function, and it shows what we call the prototype of the function, just the things that it's expecting to be passed into the function right here. On line 5. When we run this line right here, when we call the foo function, the function that was created by the class name up here, this is going to automatically call this constructor for us in order to create that object over here to the right-hand side. So I'm going to press next, and you can see that now it goes inside of this init function right here. Previous line was line 5 right here, and when we call line 5, it takes us inside of the constructor function. The very first thing that you can see is that it creates this foo instance for us on the right-hand side, and we'll be able to modify the things in this foo instance on the right-hand side. In the left over here in this blue area, this is exactly like an ordinary function that you're used to in Python, that it has two functions or two values right here, two variables that have been created for us automatically. These two variables correspond to the two variables up here that were passed into this init function. The self variable, again, the very first variable is traditionally called self, and that will always point to an instance of the class that we just created. And these subsequent variables are the variables that actually get passed in manually using the foo constructor down here when you're actually calling the constructor. This init function is never something that's called manually. It's always something that's called internally by Python for you. And the way you access it is just by using the name of the class up here and passing values into the class name. Again, we're passing one value right here. This value corresponds to the message up here. That the functions inside of a class always have this self as their first parameter. But when we're counting the number of parameters to this function, we always ignore this first parameter and only consider the parameters after the self. And because those are the parameters that you'll actually have to specify when you're calling the function. So here, this constructor, we would say takes one parameter, because when we use the constructor down here, we pass only one parameter in, but when we're inside the parameter, inside the function right here, we're actually getting two different parameters. Okay, we're currently on line 3. We're going to execute that, and it doesn't do anything because there's no default arguments right here. Line 4 is what we're doing next. Self.message equals message, and you'll see that, so I'll just press next. You'll see that it creates over here under this instance attribute, under this foo instance, this message attribute with the value of hello world. So this created this message attribute for us on line 4 using the same syntax that we saw before. Self.message, this self referring to the self inside the variable over here, this instance that Python created for us automatically, and then we created that message right here. We return none right here. It's traditional for constructors not to have a return statement inside of them. And when we return, we'll come back, finishing up line 5 down here, press next. And you can see that this A variable now, this A variable right here, has the message attribute inside of it with the value of hello world. So this line right here, combined with this constructor definition, was the same as the what we were previously doing with doing a.message equals hello world. This is a little bit more what we would call ergonomic in just programming idioms. It's ergonomic because it's easier to use. There's a little bit more boilerplate up here when you're actually defining things, creating your class, but it makes things easier for people to use because there's now only one line that you need to do to set up your foo object rather than many, many different lines. B, line 6 down here is going to do the same process, take us into the constructor, create a new instance that will be eventually the B instance when this constructor returns, and it will have the message of Hola Mundo. And there we go. So this is the same setup that we had previously in the first problem. And so when we come down here to line 8, a.message, it'll go to this message right here and not this message down here, and print that out. Any questions so far about this constructor, what it's doing? Yes. Yeah, great question. The question is, here we're only doing one attribute. What if we wanted to have multiple attributes? And the answer is, depends on your exact situation, how you're going to do it. But we could have a second attribute being passed in like this. If we say something like test here, and then self.test equals test. And then down here, we'll also have to provide some values for that test variable like this. This is one way you can have a second attribute. We'll do print a.test equals a.test like that. Visualize the execution, walk through it, and now you can see all of our instances have two attributes inside of them like this, and we can access either of those attributes. So this is one very, very common pattern of ways to do things in Python. It's also common to have attributes inside your class that are not directly like passed in from constructors. So maybe we'll have something like self.length equals length of message here. That this self.length is an attribute, and it's somehow been computed from the other parameters that were passed in up here, like this message, and so we're never specifically specifying down here what the computation for this length is going to be, but because we're running this constructor, we will be creating these lengths for us automatically. And if we'll just press last down here, you can see that now there is lengths in all of these attributes as well. Eventually, in the upcoming homework assignments, your constructors are going to be quite large, having lots of stuff that's being initialized inside of them. But they'll still only have a very small number of parameters up here. One very common pattern with constructors is having default arguments. So something like we have test equals none and message equals none like this, then we have default arguments, and now we don't have to even specify any of our arguments up here. So we'll visualize execution and come down here. When we get to line 8 down here, you'll see that this is not an error because we have values specified for these things. And so when we go inside there, no errors. Oh, I guess I did get an error right there, but because we're trying to compute the length of the message right here. But otherwise, everything's working okay getting these nones. I'm going to fix that error right there. Let's edit this code, and we'll just say if message. So that's equivalent to recall that none is a falsy thing in Python. And so if none would be false, and we would not do this right here. So we'll visualize that execution and step through this. And down here, you can see that our A instance right here has 3 attributes, and our B instance only has 2 attributes because we have these nones right here. And because there is none, we don't actually run line 7 right here, so we never create this length attribute. One of the important patterns about this, easy way to miss points on the quiz that you'll have, is that just because something has a value of none does not mean that the attribute does not exist. This attribute right here, message, exists. Its value is just equal to none. And so if I come down here and I do B, change these to B.message and B.test, this is not an error right now. This will not be an error. Let's visualize this. Let's step through this. The only difference between this current code and the previous code is I changed down here that we're going to inspect the values of the attributes of the B instance of the foo class. I just changed A to B down here, and everything else is exactly the same. On line 11 right here, you might think that this is going to give an attribute error because there's not a meaningful value inside of this attribute right here. But I did create this attribute right here. I did create it. This attribute does exist. It just has none as its value. So on line 11, when I run it, we will just print out none as its value right here. We will not throw the attribute error. So just because the value is none does not mean you throw an attribute error. The only time you throw an attribute error is if the attribute actually does not exist in this box over here. And the attribute exists in this box because it was created right here on line 4, being to the left of an equal sign. Yes, question? Pause that question. Questions about something we're going to talk about next. Before we get to that question, though, I want to do a variation on this. That's going to be probably the most common way that people will miss points on the quiz. And that's here. What happens if we move this if statement? I will move this if statement up here like that. So the only change that I'm making is I'm moving this if statement, moved it from so that it used to only encompass this length down here. Now it's encompassing all 3 of these lines. We'll visualize this execution and step through it. Nothing is going to be different about the A instance because all of this is inside of the if statement. The if statement gets true, so the A is still executing all 3 lines. We still have the same exact attributes over here, the same exact values for those attributes on the right-hand side. On line 9, though, when I run the B, create the B instance, press next. Now things will be different because the message up here is none. And now we're not going to, right here, this line evaluates to false. So we don't do any of these things down here. We don't run any of these lines. And there are no attributes created for this foo instance. Press next. And now when we try to do these things, the attribute actually does not exist. And so we throw the error, and we'll be catching that attribute error right here and printing out attribute error up here. This combines, so this is a very common pattern in Python to have a lot of none as your default arguments for constructors up here. And then the way you actually have the defaults, the way you actually specify the default is doing something like message equals salve mundi and test equals 0, whatever we want our default test values to be. Now these things, step through this a bunch of times. Back. So we've created the A and the B instance at this time. We've just finished running line 11. We're about to go to line 12. This is the state of our function over here, the state of all of our memory. And you'll see that in our foo instance down here that was created by this line 11, b equals foo right here, there are no attributes in this foo instance. But so when we do b.message, it's not going to look inside of here. It's going to jump back up to this foo class, look inside of the foo class to get the default value right here of salve mundi, and then print out the salve mundi right there. Let's see, before we get to what Henry's question was, any questions about this behavior of anything that we've seen? So yeah, Olivia first.
If there was something for messaging as would it override
yeah, I think this is one of the things that's in the actual quiz sheet. The question is, what happens now if I were to do something like foo.message equals hola mundo like this? Then how is this going to interact with this right here? And if I visualize this execution and so one of the things that you can do on Python Tutor is you can do what's called setting a breakpoint. I want to run my code up to this line right here, but go no further. So I don't want to print the values yet. I just want to run all of the code up to here without pressing next too many times. If I set that breakpoint like this and press next, you'll see that it
By any chance, are you in your room?
The step went from 1 down to 14 up here, ran all of those things and stopped
trying
at
to
the
get my
breakpoint
jacket.
right here. And at this point, this point right here, everything is exactly how it was in the previous problem. The only thing that I've done is added this line 12 right here. And on line 12 right here, you'll see that this is actually modifying the foo class itself.
It's because I have class at
about the
11.
Instance down here of part B. But when we access the instance of part B down here, it is going to access whatever is the value inside of the foo class.
I'll go to Frank. I have to wait anyway, so yeah, I'll wait for you.
And next, and print this value out, and it will give me the new value of hola mundo that we created right here instead of the salve mundi that was created up here. This is a key feature of Python that a lot of libraries do take advantage of. One of the main reasons that we have this pattern like this is so that we don't create the attributes, and that if we need to change the defaults, then it's easy to change the defaults of all possible instances that were created with the default. Was that your question? Cool. Other questions? Yes. Question is, can you create an attribute without listing it in the constructor? And the answer is yes. That so this like length right here is being created as an attribute of this instance. It is not listed anywhere as a parameter to the constructor. We've also seen that if you do something like a dot bar equals bar like that, This will, I'm going to put up my breakpoint right here on line 11. So we go up to not including line 11, press next, go up to not including line 11, delete the breakpoint, and then actually run line 11 right now. You'll see that it creates the bar instance over here. One of the things about Python that's different than most other programming languages is that Python gives you like full flexibility to do anything with a class or an object or an instance, no matter where you are in the code. Python makes no distinction about what you're allowed to do when you're inside of a function versus outside of a function, or inside of a class versus outside of a class. So the syntax for doing something here for adding an instance is a little bit different than the syntax up here, because up here we have to use self, because self is the object that we have, but the actual things that you're allowed to do is the same. The way to do it might be slightly different, but the things that you're allowed to do in Python are always the same, no matter where you are in the code. Yes. Sorry, can you say that just a little louder? These lines right here? So the question is, how do these variables right here created inside the class, how do these variables compare to these variables right here created inside of a function definition? The answer is that they have zero relationship to each other. I'm going to we'll press the first button right here. We're going to run through this code, and we're going to focus on the difference between these two variables and these two variables right here. We'll notice, first of all, that they have the same name. They have the same name. So it's easy to get confused between these variables and these variables down here. In most locations in Python, in most coding conventions, it's bad practice to use the same name in different locations, even if it's possible to use the same name in different locations. This is different though. This is extremely common in practice and strongly encouraged to use the same name here as here, because these variables are very, very closely related to each other. They're different, but they're very closely related to each other. And so the fact that these have the same name as these over here should be indicative of how close this relationship is. So I'll press next right here. Again, we're not running this class at all. We're just defining it, giving us our attributes over here. On line 10, we're going to go inside of the constructor right here, and we'll see exactly what's going on with these different variable names. The very first line up here, this is when we executed line 1, is when we created this message in this test. This message in this test are the attributes of the foo object. This message in this test, the salve mundi and 0 are the attributes of this foo object up here. On line 5, now this message and this test, same names again, but now they are local variables of the constructor function. And that's why when I want to access this message and this test over here, I would have to do something like, if I change this, another one of the things that happens inside of your quick practice problems, if is instead of doing foo, or instead of doing self, I do foo up here. How does that change things? Now this is actually going to reference the this line right here, line 7, will reference this message right here. Run that, and you can see it changed this message to hello world, because hello world right here was being passed into the foo function. And so the message inside of here, the right-hand side, this message right here is this message right here equal to hello world. The left-hand side of the equals, currently foo.message is equal to salve mundi, but when I execute this line 7 right here, it becomes hello world over here. So yeah, there's lots of weird interactions that that go on here, and being able to keep track of the local functions from the local variables from your functions versus the attributes of the class versus the attributes of the instance is the key thing to get down for this quiz. Did that answer your question, Baron, somewhere in there? Okay. If you have more questions, we can look at it later. Yes. Another variable where? Yes. Great question. So the question is, what happens if we recall the constructor, so we're gonna execute these lines again. We are calling the constructor again on line 12 right here, but when we call this constructor, we are passing in the default value of none. So this will evaluate to false, and we will not go through these lines right here. If we re-add this right here of, we'll do hola mundo like that, delete line 13 right here. Notice that I'm only adding one parameter here. This one parameter will correspond to the message. The test will remain as the default argument of none, and that's okay. Press next, step through this. Let's use my breakpoint. We'll break on this line, press next down here. And so we've created this constructor right here, and we notice that we've ran these 3 lines for the foo constructor. If we look at the instance over here for foo, there are this bar attribute comes from line 11 right here, but these lines right here did not modify the self. They did not modify the instance. They modified the class. They modified foo because foo is to the left of the dot. And so this we have hello world as our message here instead of salve mundo. And now the question is, like on line 12, though, what happens if I run my constructor with a different value down here? In this case, it's hola mundo. And so let's just walk through that. And you'll see that when we get down here, this message will evaluate to true. It's a truthy thing because it's not none. And when I ran line 7 right here, line 7 is the next line to be executed. Notice the message over here starts off as hello world, but it will get replaced by hola mundo right at this step right here, and keep going next. And I guess I still have b.message down here. This will access the hola mundo and the test equals none down here because it's going from this instance. They don't exist, so it goes up to foo, finds them here. If I change this to be a as well, then it doesn't matter whatever we put into the a constructor. It's getting overwritten by the B constructor right here. And so the A constructor is still saying hola mundo instead of hello world because it's going back to these default parameters right here. Okay, so lots of subtle edge cases to think about here. But I think my hope with this quiz is that it's not like computationally intensive, that there won't be like lots of errors because you weren't following along or you just lost track of what was going on. It's really supposed to just be testing, like, can you identify which one of these objects you're referencing at a time. So there was a previous question about why this variable is named the way that it is, and in particular with these double underscores. Anytime you see a variable or an attribute or anything in Python that has double underscores, this is something that is somehow special and built into Python. And in this case, this is a special constructor. We know that this is the special function that gets called whenever we run our class name like this. There are other special functions as well. We're going to take a look at one called the underscore repr function next. And repr is short for the representation of this class. How are we going to display this class? And the repr function, this function should return a string that will construct the class if run from Python. This is what the semantics of this function is supposed to do. We'll see how to do that here in a second and what that's going to look like. So let's return, and then we'll do this as foo parenthesis plus string self dot message plus comma plus string self dot test plus that. This is going to, we'll run this in a second and see what it actually looks like, but this is going to give me a constructor call that'll look something like this. In order to access what this repr function is going to print out, I'm just going to print out the class itself like that. So just printing a like this. I'll run this here, and I'm going to put a breakpoint right here. We'll run it up to that line. And you can see that there's this new attribute up here, repr, and it's inside of this, this objects right here. When I press next right here, line 20, when I run line 20, we're going to pay attention to what gets printed up here at the top. And let's see if I can fit all this, not quite. I'll press next right here on this, and you'll see as soon as I press next, it actually goes inside of this repr function. So as soon as I try to print out an object, as soon as I try to display an object, convert it to a string, it takes me inside of the repr function, and it runs this to get what the actual string is supposed to be that gets printed out. And so when it ran that line, it jumps straight to the breakpoint, runs this line, runs this return. We'll compute what the actual return value is. Here you can see what the actual return value is right there. Press next, and it prints that up here. This, there are many of these functions that are built into Python, and they go by a number of names. So sort of the like basic name is that they're called double underscore functions, because they start and end with this double underscore. That's how we know that they are special. Somehow Python is going to do something interesting with them, something special. But their double underscore is very awkward to say, so it's often shortened to dunder functions. If you've ever seen The Office, this sort of syntax was sort of introduced to Python at the same time as the show The Office was around, so it also is from Dunder Mifflin. And they're also called magic functions, just because they do magic depending on like what the function is. They'll have some sort of magic time when they're called. Did that answer, Henry? Cool. Any questions about anything so far? Yes. Question is, how many of these dunder functions do you need to know? The answer is, for the quiz, you only need to know this init function. Over the next month or so, we'll be introducing maybe a dozen of these dunder functions. And I don't think we will have any quizzes that specifically use those other dunder functions, but you will be implementing them and doing things with them in your projects and labs. So at this point, the only thing that you have to know for the quiz is the init function. This repr function will come up for the homework assignment, but you don't need to know it for the quiz. Okay. So the main purpose of this quiz, and really all the quizzes in this class, is to get you familiar with the mechanics of doing something, the how and the what, but not so much as the why. And the homework assignments get more into the why about things. And so now we're going to start talking about the why about using classes. And our motivation is going to be something called a generator. We're going to implement something called a generator, see a little bit new syntax in Python, and see how these classes can let us create an object that is very, very efficient, and much more efficient for a certain task than the built-in lists or tuples or arrays. In order to do this, I'm switching over to the terminal now. And again, there's this file yield examples.py in the topic 6 folder for this class. This is what we're going to be going over next. In order to get access to this file, it's posted on GitHub. So if you just update your repository to match mine on GitHub, then you'll have this exact file and you'll be able to follow along with everything that we're doing. Anytime we have a Python file, again, the habit that you should be getting yourselves into is always running the doc tests on that file. It's the very first thing that you do. So I'll do that down here, Python 3-m doc test yield examples.py. There's no output, so we pass the doc tests. So that means that we can have some confidence that while we're looking at the documentation, it's going to match up with what we would expect Python to do. I'm going to use Vim in one terminal window to open up the file, and then the other terminal window will be to run various commands related to the files. I'm going to try to do a side-by-side left and right terminal session here. Well, I'm going to go through just a couple of terminal tricks real quick in order to get things set up so that this is going to work a little bit nicely. The main reason that I want to do side by side here is that because these functions are a little bit long, they have a pretty long doc string up here. Again, the string that comes at the beginning of a function or the beginning of a file is a doc string, provides documentation in string format for that function or that file. The doc strings are relatively large, and so if we had the screen split vertically like this, it makes it hard to see everything that's going on at once, but horizontal split like this makes it easy to see the whole function at one time. The disadvantage of this split over here is that on the right-hand side, now you can see that my prompt is so big because I am in so many folders that it's taking up my entire screen and makes it really hard to see what's going on over here on the right-hand side. We've seen before that the reset command is useful for cleaning things up on your terminal sessions, but this is still, it's not fixing this particular problem. What I want to do is I want to change my prompt to be something smaller. I'm going to change my prompt to be something smaller. And at this point, I'm just going to give the incantation that does this. Later on in the next couple of weeks, we'll unpack this incantation a little bit. But there's this command export, which lets you set what are called environment variables. And there's an environment variable called PS1, which stores the actual contents of the prompt over here. And I'm going to set my PS1 environment variable to just be the $sign. So this is like the simplest possible prompt right here. And when I press enter, now you can see that my $sign is the only thing coming out over here. I can type PWD if I want to get the information about where I'm at, or I can run get branch if I want to see the branch information. So I haven't like lost any power. It's just a little bit less convenient to see it all at once. But now everything fits on the screen nicely, so it'll be more convenient for our purposes. Okay, so on the left-hand side here in this file, we're going to be introducing something called the yield keyword. So this is going to be a new Python syntax that you'll have to do for your homework assignment, but again, not something that will be on the quiz at all. And we're going to introduce this idea of memory complexity for a function that so far we've talked about runtime complexity of functions. We're going to talk now about memory complexity. And the main purpose of this yield keyword is going to be to improve the memory complexity of our functions. We'll start here going through just each of these examples one at a time, what they're going to do. And each example is each one of these functions is going to build off the previous ones, doing something a little bit different and introducing some different problems that we'll have to fix. On line 5 right here, our first function we're defining is the factorial. So we have our big doc string, and then down here, it's just computing the factorial of the input number. So again, the factorial is just if you multiply from 1 up to n, all those numbers together, you get the factorial. And so the factorial grows very, very large, very quickly, but it's very easy to compute right here. Here I'm saying that the computational complexity is theta of n. The reason that it is linear right here is because we have a single for loop right here. And inside that for loop, the only thing that we're doing is a little bit of multiplication. There's no like container operations going on. I'm not talking about best and worst case or any of the different cases of computational complexity, because in this case, or in this function, there's no actual container. So like whatever the number is, that's the only possible case. Just abbreviating worst case complexity as computational complexity. And that's theta n, that no matter what n is, it's guaranteed to run no more than n times this for loop, and it must run all n of those iterations through the for loop. Hopefully this first function is relatively straightforward, and this runtime down here is relatively straightforward. We're going to go on next to see this all factorials function. And we'll first take a look at the doc tests right here to see what exactly it's doing. Again, the purpose of having doc tests is to provide documentation about what functions do so that people don't have to run the function themselves. They can just look at the output down here to understand the function. And by running the doc tests earlier when we did the Python 3-m doc test like that, and then the name of the file, we actually already ran these just to double check that this output is in fact the output that we get. Here, the difference between all factorials and the previous function is now that instead of returning just a single number, like what is the actual factorial of this number, we return all the numbers between 1 and whatever the number is that we're calculating. So the last number out here in particular is the result of just the factorial function with this input. But now we'll have a list whose length is whatever the input in value is. If you look at this function down here, at first glance, this function looks like it has a linear runtime. At first glance, this function looks like it has a linear runtime because there's only a single for loop inside of it. If we analyze this a little bit more carefully, we'll see that there's this append operation. The append operation is happening on a list. And if you go back to your list notes, you'll see that actually the append operation is also a constant. So this O of 1 right here times an O of n looks linear. A lot of people would look at this, a lot of professionals doing a quick glance would look at this and just say, oh, this is a linear runtime. But this runtime is actually quadratic, because inside here, this factorial call right here, this has a linear runtime as well. So this right here is O of n, and it happens inside of a for loop that happens in times. Because they're nested, you multiply them together, and so you get a quadratic runtime right here. This is bad because a quadratic runtime is not necessary for this problem, and so it is much, much slower than we should be able to do. If we look down here, I have this note right here, and this is saying it's introducing this term called accidentally quadratic. And having functions that are accidentally quadratic is one of the most common problems in professional software development. Every software system that you have seen before has had bugs related to somebody doing something like this, thinking that what they were doing was linear and it's actually quadratic. There's this really famous programming blog called Accidentally Quadratic. And if you go over to it, I have it pulled up over here. They have just dozens and dozens of famous cases where a company's website, for example, goes down because some programmer did something that they thought was linear but turned out to be quadratic. Some examples here. So Elasticsearch is a really famous search engine. Even Vim has had this problem in different situations. I want to go here, Chrome. So Chrome, it's possible to take over somebody's computer in Chrome at one point because of a bug related to being accidentally quadratic. So it's very important to get into the habit of trying to be able to spot these things and say, unacceptable. We want to get something that's actually a linear runtime. This all factorials 2 fixes the accidentally quadratic function above, making the runtime linear. The way it does that is that we realize that when we're computing, say, the factorial value of 10 right here, we don't need to recompute everything that happened before. We already have the factorial value of 9. And so if we sort of basically actually substitute the definition of our factorial function right here, then we'll get the linear runtime that we're hoping for, theta of n instead of n squared. This is a good stopping point for us. Next class period, we'll talk about the actual, like, what's the problem with this still? It's using too much memory, and how to solve that using this yield keyword and classes. So again, quiz on recursion on Wednesday. And anybody has any questions about anything, I'm happy to stick around and get those answered for you.